Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adi Nu'man bin MAAFKAN and my friend Muhammad Syafiq Aiman bin Kamarudin from Group 4 EE112BA. Our group will present about mobile and cellular communication. Next, I want to present for all of you guys about illustrate the frequency reuse concept in mobile communication. What is frequency reuse? Frequency reuse is the process of allocating the channels to more than one cell, provided that the cells are separated by sufficient distance. Frequency reuse. First, cellular technology enables mobile communication because they use a complex two-way radio system between the mobile unit and the wireless network. 2. It uses radio frequencies, which is radio channels over and over again throughout a market with minimal interference. 3. It serves a large number of simultaneous conservation. This concept is the central to cellular design. Next, main objective of frequency reuse. First, to keep the transmitted power from each base station to a minimum. Second, to keep the position of the antenna of the base station just high enough to provide for the area coverage of the respective cells. Frequency reuse have two, which is advantage and disadvantage. Advantages and disadvantages. The advantages, first, many transmitter of small output power operating at the same frequency can be used. Second, it reduces the minimum height of the transmitting antenna. Disadvantages of frequency reuse. Co-channel interference can occur if system is not properly designed. Co-channel interference means a phenomenon in which two frequency signals of adjacent channels interfere with each other. Frequency reuse concept. We can look at this shape, which is the hexagon shape. The frequency reuse have cell and cluster. The coverage consists of 3 clusters. Yes, we have 1, 2, 3 cluster, and each cluster has 7. Okay, each cluster has 7. 1, 2, 3, 4, 5, 6, 7. Each cell assigned the same number of full duplex telephone channels. Point number 4, cell with the same letter use the same set of the channel frequencies. The characteristic of frequency reuse. Most frequency reuse planes are produced in groups of 7 cells. Same frequency is reused by each other. Same frequency is reused by each sector. The number of cells per cluster define the reuse pattern. This is a function of the cellular geometry. Cell sizes vary from some 100 km up to 35 km depending on user density, geography, transceiver, power, and many more. The hexagonal shape of cells is idealized. So the frequency reuse is hexagon shape. Last characteristic is by limiting the coverage area to the boundary of the cell, the channel groups may be reused to cover different cells. Go to the calculation. Consider a cellular system which has a total of S duplex channel. Each cell is located a group of K channel, which is K less than S. The S channel are divided among N cells. The total number of available radio channel S equal to Kn. The N cell, which is the complete set of channels, is called cluster. The cluster can be repeated n time within the system. The total number of channels C is used as a measure of capacity. C equal to MKN equal to MS. The capacity is directly proportional to the number of replication of N. The cluster size N is typically equal to 4 until 7, 4, 7 or 12. Small n is desirable to maximize capacity. Lastly, the frequency reuse factor is given by 1 over n. Next, Shafiq will briefly about cellular system topology. Thank you for me for lending your ears. Assalamualaikum warahmatullahi wabarakatuh.
Hello, Assalamualaikum. My name is Muhammad Shafiq Aiman bin Kamuruddin. My matric number is 2019266446. I want to continue our presentation with cellular system topology. So what is topology? The term topology refers to the way in which the endpoint or station computer system attached to the network are interconnected. We move to our next slide. Topology has 6 different types. First, mesh topology. Second, star topology. Third, tree topology. And then bus topology, ring topology, lastly, cellular topology. Today, I want to present about cellular system topology. Radio network is defined by a set of radio frequency transceivers base stations located within each of the cells. Figure 5.8 illustrates a simplified cellular telephone system that includes the basic component, which is mobile unit, base station, and mobile telephone switching office, which is MTSO. So figure 5.8 will illustrate what the cellular system topology. Next, what is mobile unit? Mobile unit communicate directly with the base station over dedicated data link, metallic and non-metallic. And the base station communicates directly with MTSO over free space or airwaves. Next, base station. Base station serves as central control for all users within a cell. It also consists of a low power radio transceiver, power amplifier, and cell side controller. It also provides an interface between mobile telephone sets and the MTSO. Lastly, mobile telephone switching office, MTSO. It controls channel assignments, call processing, call setup, and call termination. Includes signaling, switching, supervision, and allocating radio frequency channels. It provides a centralized administration and maintenance point for the entire network. It also interfaces with the public telephone network over wireline voice trans for the conventional wire telephone and interface with data link. Most MTSO are connected to the SS7 signaling network, which allows cellular telephone to operate outside their service area. So this is link our group refer to get info. That's all from us. Thank you.